Thanks for joining, everyone. I'm excited to be here today. We'll be talking about the role of open source in the enterprise Gen AI applications. And today's webinar, it's going to be divided in three sections. I'm Juan Pablo from Canonical. And in the first section, I will be covering the open source tools that can be used to build your own RAG systems. In the second section, we will have Ron from Microsoft, who will take us through the role of Azure as public cloud running RAG on enterprise. Then Jan from Intel will show the exciting technologies Intel leverages to optimize your Gen AI workloads. So let's begin. Large language models are a technological advancement in natural language processing. Now computers understand our language and can respond accordingly. So something as natural as a conversation interaction with your computer can emerge. LLMs, large language models, is a technology you probably already use, adapting it to your needs for work or personal life. Tools like ChatGPT, Cloud, Gemini, and Copilot are not just names. They are powerful tools that you can use to significantly enhance your productivity, empowering you with their potential. However, there are two critical problems when you plan to use similar tools to boost your work and your productivity. The first one is going to be precision. Imagine that you get pulled into a meeting without proper contextualization. Your manager asks you a specific question critical to the conversation. And since you are a sharp professional, you will either figure out a broad answer from your expertise on the spot, or just say that you don't have enough information to provide a precise answer. In this scenario, the lack of context can compromise the precision of your answer. And your main goal is to be as helpful as you can. And sometimes rushing to provide an imprecise answer can be misleading for a conversation. It's the same for LLMs. They are trained and fine-tuned for specific tasks, but their training can become updated or may not encompass all the necessary information, which is a crucial aspect to be aware when you're relying on LLMs to help you in your work. There's where retrieval augmented regeneration, or RAG for short, comes into play. In the scenario with your manager, RAG is the equivalent of receiving an email ahead of time with all the required information and contextualization, so you can prepare for that meeting to be as helpful and precise in answering those questions. The ability to ingest, store, search, and retrieve that information, which later will be served as the context for your LLM application, can differentiate between your LLM providing precise and helpful answers or just broad generic answers, even hallucinations. The second gap is confidentiality. In the same scenario, that conversation is also confidential. You will carefully use the approved channels to exchange the required information. Suppose that you are trying to improve the precision of your answers on a third-party LLM outside your organization's control. In that case, it might be tempting to provide context as part of the prompt, but by doing so, you are compromising the confidentiality of the organization. So that's where retrieval can act as a gatekeeper. As LLMs comes with larger context window, dumping the entire organization data into the LLM prompt, as I said, can be tempting, but it risks exposing the information information to the model and the users of your tool. To address these gaps, an end-to-end RAG workflow can be implemented, as RAG systems by design can enforce access controls by retrieving only the content the user is allowed to know by built-in filtering capabilities on the retrieval stages. These end-to-end RAG workflows can be implemented in your public or private cloud using open source solutions. So next, the question is, how can you build a RAG based on open source solutions? There are two key components that can be used and are going to be instrumental into these kind of solutions. The first one is going to be OpenSearch, that it's a search engine with vector database capabilities. And Apart from its vector database capabilities, it offers also a vast set of machine learning tools that can be leveraged to enable complex solutions in the natural processing language applications. The second one is going to be Kubeflow. Kubeflow is a platform that enables the optimal use of hardware resources like GPUs and provides a complete ecosystem for data scientists and engineers with tools and frameworks for each stage of the machine learning lifecycle of your solutions. So, how do we build an end-to-end RAG workflow? Well, we will be using the features that we need from these two tools to build a reference architecture. So OpenSearch can provide a front-end API for conversational applications with a role-based authorization model, which is pretty important, as we saw in the confidentiality part. A KNN index with a sentence transformer pipeline to ingest, store, and then retrieve the embeddings of and the relevant text to be used as the context of the RAG for the RAG LLM. We can also use OpenSearch to create memory indexes, so we can store the conversations and provide complete conversational flows to our users. And we can enable connectors to external LLMs APIs that we will be inferencing later in one of the Kubeflow components called KeyServe. Additionally to this, OpenSearch offers other tools like guardrail filters for the inputs and outputs of the LLM. So then we have Kubeflow, and as I mentioned, particularly KeyServe, it's the model inference component of Kubeflow that provides an inference server for the selected LLM with GPU-based acceleration and compatibility with several CPU-based accelerated formats like GOOF, for example. An OpenAI compatible chat completion API, so you can interact with it and use as you have been using some of the other well-known LLMs out there. A queue proxy for the generation request, and the auto-scaling capabilities for the inference services. To orchestrate these solutions, Juju is the lifecycle operator for these applications that allows you to easily deploy, integrate, and then operate to your RAG and other GenAI applications with a vast set of applications that Canonical offers in its MLOps portfolio. So whether it's on-prem or whether it's in the public cloud, you can use Juju to operate your solutions. Now, I would like to pass it to Ron, who will show us why Azure is the hyperscaler of choice for running your GenAI open source workloads.
All right. Thanks, JP. So let's talk about why customers choose Azure in the first place for RAG deployments. So just a quick background from an Azure perspective. A lot of customers don't realize that Microsoft Azure is actually mostly open source type of workloads that run on the Azure cloud. The reason why that's important is that many of the new AI and model technologies out there are based on Linux workloads and Linux, and open source tooling. So this is really important because Microsoft has been spending the last few years really prioritizing, contributing back into the open source community. And of course, many of you know that Microsoft has partnered with OpenAI. So when you look at all the different technologies and partners that leverage Azure, that run on Azure, Azure now runs 66% of Linux workloads. So a lot more than Windows and SQL, which is surprising to many customers. But this is really important because if you look at a lot of the tooling out there from an open source perspective, these are all Linux-based technologies, and they run perfectly fine and even better on Azure. So if you see that there's hundreds of Azure services that even run it, including Xbox, LinkedIn, Bing Chat, and of course, things like Minecraft and Azure Kubernetes service, right? Which underpins a lot of other workloads as well. So you see that Azure is a fantastic place to run these workloads. So that's one of the basic reasons why customers choose Azure for their RAG models. All right, so let's talk a little bit about specifically why Azure is a great platform for the RAG pattern itself, right? Just like LLMs, which are pretty much trained on on a set of data. When you want to be able to get into to RAG patterns, you want to be able to not only leverage the natural language models available, but also be able to pull data sources in real time. So that easy access to data is a huge component of making a RAG, model performant and useful for your use case. So the ability of being able to access that data really quickly, and of course, if you have petabytes or even exabytes of data, it's very tough to store that on-prem or in a colo. So this is really where the hyperscalers like Microsoft Azure are a fantastic place to put these type of workloads. So not only the access to storage, it's the different types of storage as well. So as you know, OpenSearch is, it has a backend database as well. But many customers have their data in all sorts of different, locations and technologies, whether it's a NoSQL database or a structured, SQL type of database, or even an analytical data stores as well. So the fact that Azure gives you the capability of storing all sorts of data in one cloud, in one umbrella, and being able to throw hundreds or thousands of compute accelerators to compute on that data, like the Intel chips, gives customers a great platform to be able to run their RAG patterns. The other reason why, like I talk to customers about why Microsoft versus some of our competitors is that, many of the competitors have locked those models down on only a couple of very specific type of models. So they're only optimizing for maybe just one or two. The way that Microsoft approaches AI is that we're taking a multi-model approach. So this is something that Satya is very passionate about, is that not only are we good partners with OpenAI, but we've even partnered with Meta for their Llama models, Mistral, Anthropic with Claude and Sonnet. That's also huge with some of our VS Code work that we do. Cohere, even working with Elon Musk's XAI, right? The Grok model runs on Azure as well. And even Microsoft in-house models have been built as well. So customers have the freedom to choose which models work best for their workloads, right? And be able to train off, on their data on any of the models that they choose. So that's the reason why that Microsoft Azure is really a standout when it comes to these type of RAG patterns. Is that other customers and all these different companies already run that type of model on Azure, so it's very much optimized to run those workloads. So one of the things that we've done is partnered with Intel to make sure that those accelerators are accessible for customers to be able to use. So here's a quick snapshot of some of the data center regions. Azure is really a global implementation, and we worked with Intel to make sure that they put their accelerated chips into our data centers. So whether it's the DSB4s or DSB6s, whether it's the AMX or TME accelerated chips, you can see here there's over 60 different Azure regions that have that technology. So whether you're a global customer or just have a global application that you want to run, Azure has all these accelerated chips in different locations. So let's talk about the how, right? So not only do we have the capabilities on being able to enable this for customers, we also want to make sure that the customers are safe and secure, and that their models, run performant and securely on Azure. So trust is a big factor on being able to run these workloads because many customers are developing their own intellectual property. So it's really important to have the best practices enabled from the get-go. So it all starts with things like network isolation, making sure that the customers who deploy their RAG patterns on Azure have a very secure environment that only they have access to, that will not be something that other customers can see, for example. So using virtual networks is pretty much one of the table stakes in a deployment here. And of course, data security comes in all sorts of different layers, whether it's data at rest or data in transit. So we provide multiple types of encryption options, whether it's on the Azure security layer with service encryption, or on the disk layer, right, to get you disk encryption. And of course, things like TLS, SSL from a network transport perspective to make sure that data in flight is secure. And of course, when customers really want to go big on their models, we can be talking about petabytes or exabytes of storage, which means also a lot of compute. So from a horsepower perspective, you really need a lot of performance, networking, storage, and really the hyperscalers like Azure are really the only ones capable to scale up to that level. So the performance, the scale, the access to the different data sources is going to be huge to allow customers to be able to run their models efficiently. So once that implementation is in Azure, it's really also important to keep monitoring that and log it as well. So that way you can see if the right people are accessing it properly, and be able to detect any anomalies and that sort of thing. This helps gives customers peace of mind that their implementation has the right security posture, is performing accurately and performantly, and ensuring that only the people that are given access to that infrastructure are the ones able to actually run those models. And of course, many of our customers also have compliance requirements as well, right? Whether you're in the federal government or state and local government, or maybe you have, vertical requirements, say, for example, like the financial services industry, or maybe whether you're in the energy industry, right? If you're a utility, there are lots of different regulations that may apply to specific customers. So we'll help you with those as well. So this is another reason why we partner with Canonical. Many of those workloads, that I talked about earlier, a lot of those tools are built on top of Canonical Ubuntu, right? And Ubuntu Pro takes that to another level, because really what customers want from a production standpoint, when they really want to start getting their applications accessible and available to their customers, they want to make sure that it's a trusted and secured platform. And Ubuntu Pro gives that to customers. So everything I mentioned about on some of those best practices, Ubuntu Pro takes that from an operating system perspective as well. So from a data security perspective, the performance, right? We work closely with Canonical, and even tuning the Ubuntu kernel to make sure that it runs very well on Azure and very well with the accelerated chips out there. So of course, there's also the operating system level of monitoring and logging, and the compliance, and as well as the open source supply chain security, because there are so many, it's tens of thousands of packages out there that could be created by all sorts of folks and vendors, and you want to make sure that those are scanned, that they don't have any vulnerabilities. So Ubuntu Pro gives you that peace of mind that not only is there like a 10-year patching schedule that you don't have to worry about, it also just makes sure that all those packages that are available are going to be trusted. So that's a huge reason why we partner with Canonical and Intel on many of these type of workloads. All right, so I'll turn it to my Intel counterpart to talk a little bit more about the Intel accelerators themselves and how they're used for those RAG patterns.
Thank you so much, Ron. So, hi, my name is John, and I'm an AI and cloud architect at Intel. I've been in this field for also over 18 years, the data analytics and AI space, and lately I've also dived into a lot of AI work, and it's also become my hobby as well. But today I want to go over with you how you can make use of Intel technologies in order to take maximum benefit from an AI RAG pipeline. So in the earlier slides, you heard about the amazing technologies getting built at Canonical and the vast scale that Azure provides, like 60 plus regions. That is phenomenal, right? Now, what I want to do is specifically give you a brief context on the role that Intel plays in this pipeline. It is very likely that some people know Intel is primarily for its hardware, such as CPUs and GPUs, right? But we also invest heavily in the software and other technologies. In fact, that's less known is that Intel has an extremely rich history of making open source contributions, right? We've been one of the top contributors to many years to the Linux kernel, PyTorch Foundation, PyTorch libraries, and other open source frameworks, but also to the more recently to the OpenSearch, right? And we'll be talking about that. We believe in fundamentally enabling technologies at a foundational level where possible, and we try to do it implicitly so that the users can directly start leveraging the benefits. This applies to the accelerators that I will be talking about, right, in the next slides. So our end vision is basically to have an environment where the developers spend as the end vision is to have as little application side changes as possible, right? So ensuring that all of your libraries are pre-optimized and all the dependencies are running at their best possible performance with all the security guarantees, and everything is basically ready for the developer to use. So Intel plays a critical role in this, right? There are multiple stages of the retrieval augmented generation pipeline, right? And within this workflow, there are common performance-intensive components, right? To name a few, vector databases, embedded models, inference engines, and these are areas where Intel provides optimized solutions, hardware accelerators that are already widely available across major cloud providers like Azure and also on-prem, enabling developers and organizations to take an advantage, right, with minimal effort. And that is our goal. So let's consider here a typical performance hotspot, right, in the data management layer of the rack pipeline. So that's basically, we can give a very common example here, right, with the vector database that powers the retrieval process, right, the foundation of the rack pipeline. So let's take OpenSearch as an example. So when profiling such a setup, right, the substantial portion of processing time is often spent on two key tasks: building the KNN index and executing the neural search queries, right? During these operations, what happens is an in-memory graph is basically constructed to represent the vector relationships between the data points, right? This process is computationally very, very intensive and is a very good prime candidate for optimization through vectorization. So in this diagram as well, we can see the green stack, right? The left-hand side shows you the KNN index field, and right cluster shows you the neural search. And here is where Intel architecture can really make a big difference, right? Using Intel's AVX 512 acceleration, which is already supported on platforms like Ubuntu and integrated with OpenSearch, workloads can achieve measurable performance gains. In our internal experiments, we've seen optimizations that have resulted in up to 35% speed improvements on index build and query operations. So what's happening, though, under the hood? Yeah. So AVX 512 basically works through a technique called SIMD, right? Single instruction, multiple data, right? So rather than parallelizing tasks at the application level, SIMD parallelizes at the data level, right? That is key because it allows multiple data elements to be processed simultaneously within a single CPU instruction. For developers, the key advantage lies in leveraging wider registers, applying minor code level optimizations, and gain big achievements with throughput. Essentially, this enables true data processing where multiple layers of computations happen concurrently. This significantly accelerates the overall workload without requiring a complete application rewrite, and that is key. Next slide, please. Yeah. So, okay, that was a good example of AVX 512 and how we benefit from it, right, within the AI rack pipeline for within data management. Now, let's also talk about the various accelerators that Intel has. The list you see here, this is not the full list, but today what I want to do is more focus on the ones that are related with the rack pipeline, the confidentiality side of it, security side of it, and then performance side of it, right? So starting with the first one, AVX stands for Advanced Vector Extensions. AVX 512 is the latest in the series. The predecessor, named AVX2, which uses 256-bit registers, right? AVX 512 introduces SIM registers, which are 512 bits wide. So AVX 512 is especially valuable for workloads that rely heavily on vector processing, such as operations such as semantic search, neural search, other vector-based retrieval tasks, which we just went over in the example in the previous slide, right? And you can see on Azure, they're available on a wide variety of virtual machines. The D and E series of V4, V5, and V6 series, all of these instances will allow you to use this accelerator. Next, let's talk about a very important accelerator as well, called AMX. This is available with the 6 family of VMs within Azure, right? The D and E family V6 series. This accelerator is very suitable for machine learning and the AI scenarios that could happen on CPU. So the solution positions Intel in the inference space, which is very compute intensive as well. AMX typically operates on matrices, and if you're familiar with the inference problems, there's a lot of it involves around matrix manipulation, right? AMX leverages the CPU to perform matrix calculations, multiplications, and that by giving significant speedups to the inference portion of your workload. The EC and DC V6 series are also used for confidential AI, right? On top of this, which we will talk about in the next slide. So I'll pause on that for confidential AI, the EC and DC series, right? And what AMX adds is basically a new type of register. We call it the tile registers, right? They basically store the 2 small dimensional blocks of data. It includes a special instruction called TMUL, right? That multiplies 2 of these tiles and adds the result onto a third one. AMX can handle many of these tile operations at the same time, making it much faster for matrix-based calculations. And basically, that's what's happening under the hood. Right? So, and last but not least, I want to also talk about TME, which is basically another technology and accelerator available on Azure, which stands for Total Memory Encryption. The functionality of this accelerator is to encrypt all the data that's written to the DIMM. This allows you to defend your memory against any sort of physical attacks, like if there's any external or internal attacks to the physical memory, then you could defend yourself and guard your application against all of those external threats. Now, if you can go to the next slide. Yeah, thanks so much. So I mentioned I want to talk about confidential AI, right? So now on this one, let's talk about how we as Intel enable confidential computing in AI pipelines, right? Especially for the retrieval augmented generation workloads running on Azure. So encryption in transit, for example, HTTPS, and encryption at rest when you store the data, they're both very mature, widely implemented production methods. However, data in use, so the moment data is being processed in memory, that remains a distinct and less mature risk surface, right? To be processed by the CPU, the data must be in clear text in RAM. So that creates a brief but critical exposure window where data can be sniffed or accessed by privileged software. Intel's confidential computing technologies, SGX enclaves, and TDX trust domains are designed to close that window by keeping code and data protected in hardware, that is key, hardware isolated memory, and providing attestation that the runtime is genuine. So in short, right, network and storage encryption protect when data moves or rests. SGX, TDX protect while it's being computed. So at a high level, confidential computing protects data used by creating hardware-enforced trusted environments where code and data remain isolated, even from the cloud provider or the system administrator. Intel provides a comprehensive portfolio here with Intel SGX and TDX and Intel Trust Authority, each addressing a different level of protection and also different type of protection. So starting with Intel SGX, right? Or we can also call it as software guard extensions, offers the smallest trust boundary. It protects sensitive parts of an application, such as key management, token angling, special machine learning routines inside secure enclaves. It's ideal when you need fine-grained isolation at the code or data level. Intel TDX, or you can also name it as trust domain extensions, take this to the virtual machine level, right? And that's basically the difference between them. It creates what we call trust domains, hardware isolated virtual machines that safeguard your entire workload, the operating system, the model, the data from the rest of the infrastructure. So what makes TDX particularly valuable for AI is that you get strong protection without any changes to your application or programming model. You can simply lift and shift your existing RAG components, or if this were to be a non-RAG AI model, right, you could also do that. But you can easily do that with RAG components. Your vector database, embedding model, inference engine into TDX-enabled confidential VM. The second major benefit that I want to talk about is that the TDX provides robust isolation, integrity, confidentiality for both your AI data and your models. So you ensure that sensitive vectors, embeddings, model weights remain protected even from software like the hypervisor or the cloud admin, as we talked about. Third, TDX allows you to run machine learning processes on highly sensitive information, things like proprietary knowledge bases, regulated data, customer IP, while maintaining your full assurance that runtime environment remains confidential. Finally, I want to talk about the Intel Trust Authority, sometimes also referred as Intel Hybrid Trust Services, provides independent attestation layer. So this is a bit different, right, than the Intel TDX and SGX. What it does is it lets you verify that your confidential environment is genuine and properly configured, and it does that from an independent perspective, right? Whether you're running on Azure, on premises, or even at the edge. So together, SGX, TDX, and Trust Authority form a complete framework building confidential AI, ensuring that your RAG pipelines can operate securely, compliantly, and with verifiable trust in the cloud. Yeah. Over to you, JP.
Thank you very much, Ron and Jan, for your insightful participation in this webinar. For following up with how Canonical can help you to meet your needs of open source on top of Azure, please scan this QR code, and we're looking forward to hearing about your GenAI applications and endeavors. Thank you very much.